Okay, so last lecture we have seen what are the different properties of relations. In that we have seen reflexive property, symmetric, transitive, antisymmetric, and irreflexive property. So there are total 5 properties of relations we have seen yesterday. So today we are going to solve some examples based on it. Okay. So question number 1, define a relation between two sets A and B where A is containing elements 5, 6, 7 and B is containing elements X and Y. So from these two sets we have to define one relation. So what is the definition for relation? Yesterday only we have seen relation is set of order pairs. Okay. Now from these two sets we have to form order pairs and collection of all these order pairs form a relation. Okay. Now consider the first element from set A. That element is 5. So we can write order pair as 5 comma x, 5 comma y. Now next element is 6. So we can write order pair as 6 comma x, 6 comma y. And then last one is 7. So 7 comma x and 7 comma y. So collection of all these order pairs forms a relation R. So in this way we can define any relation from given sets. Have you understood this problem? Hello? Have you understood? Okay. Now, second problem is given as consider the relation S, and this is consist of these order pairs. Then find domain and range of relation. So last lecture we have seen what is the meaning of domain and range of relation. So now you have to tell me what is domain and range of this relation S. So D of S means what? Domain of relation S. So what is that domain here?
AP.
1, 3, A, P. Correct. And range? What is the range? Range always refers to second element of each and every order pair. So 2, 4, P, Q. So this is the answer for domain and range of given relation. Now next question is given. Let P is equals to this relation. Q is given as this relation. Then find P union Q, P intersection Q, domain of P, domain of Q, domain of P union Q, range of P, range of Q, and range of P union Q. Okay. So two relations are given, and from these two relations we have to find all these things. So first of all, tell me what is the answer for P union Q? So already in this set theory we have seen what is the union operation. What is the answer for P union Q? Union means what? We are going to combine the elements from both the sets. Okay. Now here P and Q are relations. That's why elements of those relations are order pair. So whenever we have to perform this union operation on relations, we have to just combine order pairs from both the relations. So answer for P union Q is order pair 1, comma 2, 2, comma 4, 3, comma 3, 1, comma 3, 2, comma 4. That is repeated. So this not requires to write it again. And last one is 4, comma 3. So this is the answer for P union Q. Now next one is P intersection Q. So Now tell me, what would be the answer for P intersection Q? Intersection means,
order 2, 4.
yeah, order pair 2, 4. This one, the order pair which is common between both the relations P and Q, that will be P intersection Q. Correct. Now next one is domain of P.
1, 2, 3.
1, 2, 3. Then domain of Q. 1, 2, 4. Then domain of P union Q. We have already found out.
One,
Yes, 1,
1, 2, 3, 4.
1, 2, 3, 4. Correct. Then range of P.
2, 4, 3.
2, 4, 3.
4,
Range of
3.
Q. 3, 4,
3,
3.
4, 2.
Correct. And range of P union Q.
2,
2,
3, 4,
3,
2. 4.
Yeah.
2, 3, 4.
2, 3, 4. Correct. Now, next question they have asked, show that domain of P union Q is equals to domain of P union domain of Q. Okay. So, we have already found out what is the answer for domain of P union Q, and that is set 1, 2, 3, 4. Now, what is the answer for domain of P? It will give you 1, 2, 3, 4. The P union Q is equals to domain of P union domain of Q. That we have shown now. Likewise, we have to show range of P intersection Q is subset of range of P intersection range of Q. Okay. Now, we have already found out what is the answer for P intersection Q. Now, we have to find what is the range for this intersection operation. Yes. So what would be the answer for range of P intersection Q? P intersection Q we have already found out. So just we have to think about what is the range of this P intersection Q. So again, range is what? It will refers to second element, and that element is 4. So answer for range of P intersection Q is it is 4. Now, we have to show it is subset of range of P intersection range of Q. Now, what is the answer for range of P? That we have already found out value for range of P, and that is 2, 3, 4. Again, intersection range of Q. Range of Q is again 2, 3, 4. So here we can show that 4 is a subset of this 2, 3, 4 because 4 is element of this set 2, 3, 4. That's why 4 is a subset of given set. So here we can say that range of P intersection Q Hello? Hello? Am I
Yes,
audible
ma'am.
now? Okay. Have you understood this problem? Question number 3. Hello? Okay. Now, next question is given. What is the range of relations S and T, where S is equals to order pair x comma x square for every x belongs to n, and T is given as order pair x comma 2x for every x belongs to n, where n is set of natural numbers, that is 0, 1, 2, all these numbers. Then find S union T and S intersection T. Okay. So first of all, we have to find out the relations S and T from given conditions. So first condition for S is we have to find out such order pairs such x comma x square. This one, if first element is 1, then second element must be square of 1. If first element is 2, then second element must be square of 2. Likewise. Okay. And we have to start the value for x from 0. So first, if you put the value for x here as 0, you will get first order pair as 0, comma 0. If you put 1 there, then 1, comma 1. If you put 2 there, then 2, comma 4. Likewise, we can find out the order pairs for relation is. Okay. If you consider T, so for this T, we have to include order pairs x comma 2x. So now start with the 0. So 0 comma 0, that is the first order pair. Then 1 comma 2, then 2 comma 4, 3 comma 6, 4 comma 8, likewise. Okay. So now we have to perform union and intersection on these two sets of these two relations. So first S union T, here we have to combine all the order pairs from both the relations like 0, comma 0, 1, comma 1, 1, comma 2, 2, comma 4, 3, comma 6, 3, comma 9, like this. And S intersection T is here we have to find out the common order pairs from both the relations. And the common order pairs are 0, 0 and 2, 2. So likewise, we can find any relation and we can perform operations like union intersection on it. So these kind of problems they are asked in university exam. So you have to first find out what is the relation for this given defined set, and then we have to perform the operations like union and intersection. Next question. Set X is given, which is consist of 4 elements 1, 2, 3, 4, and it is given that there is one relation R which is consist of order pairs x comma y such that x belongs to capital X and y belongs to capital Y, and x minus 1 is an integral non-zero multiple of 2. Okay. So here this is the given condition for relation S. So likewise again they have given relation R, and then they have given condition for relation S. A relation S will include order pairs x comma y such that x belongs to capital X, y belongs to capital Y, that is set x and set y, and x minus y is an integral non-zero multiple of 3. Then we have to find out what is the union and intersection of these two relations. Okay. So for that purpose, first we need to find what are the different order pairs in relation R and S. So first of all, we are going to consider relation R. So here we have to define these two relations on set X, where X is containing 4 elements, 1, 2, 3, 4. So first, we have to consider order pairs such that X minus 1 is an integral non-zero multiple of 2. So here we can find first order pair as 1, 3. Why we have taken this order pair? Because 1 minus 3, it will give you minus 2, and this is the non-zero multiple of 2, because it will give you answer as minus 1. That's why we can add that pair in relation R. Likewise, 3, 1 is there. So again, 3 minus 1, it is 2. So 2 is multiple of 2. That's why we can add that over there. Likewise, 2, 4. It will give the answer as minus 2. So again, it is multiple of 2. And last one is 4, 2. So 4 minus 2, answer is 2. So again, it is multiple of 2. That's why here we have to add all these 4 order pairs in relation R. So likewise, we have to find the order pairs for relation S. So can you tell me what would be the different order pairs those we can include in relation S?
1, 4.
1, 4. Yes. 1 minus 4, it is minus 2. 4, 1. Okay. Is there any another order pair? No. So only these two order pairs we can include in relation S. Now we have to perform union and intersection operation. So union means what? Again we are going to combine order pairs from both the sets. So R union S is 1, 3, 3, 1, 2, 4, 4, 2, 1, 4 and 4, 1. So here we have just combined order pairs from relation R and S. Now next one is R intersection S. Now check whether any order pair is common between these two relations. No. So here nothing is common between these two relations. That's the answer is 5. Next question is given. Let L denote a relation less than or equals to and D denote a relation divides. Where X is in relation D with Y means what? X divides Y. Both L and D defined on set 1, 2, 3, 6. Then we have to write L intersection D. Okay. So set X is given, which is consists of 4 elements as 1, 2, 3, 6. And what they have asked, here we have to find L intersection D. So first of all, we have to write what is the relation L. So L is relation that is less than or equals to relation. So first of all, we have to find all such order pairs. Those are satisfying this condition less than or equals to. Therefore, the first element of that order pair should be less than or equals to second element of that order pair. So likewise, we can write the order pairs as 1, 1. So here both the elements are equal. Second one is 1, 2, 1, 3 and 1, 6. Okay. So likewise, again we can write 2, 2, 2, 3, 2, 6. Then 3, 3, 3, 6. And last one is 6, 6. So all these order pairs will be included in L. So likewise, we have to find out the order pairs for relation D. And that relation is divides relation, where X divides Y. So we have to include all such order pairs such that first element of that order pair divides second element. So can you tell me what would be the different order pairs those we can include in relation D? Yes. What are those order pairs? Those order pairs must satisfy divides relation. Yes. So here we can include order pair 1 comma 1 because 1 divides 1, again 1 comma 2, 1 comma 3, 1 comma 6 because 1 divides all these elements. Now if you consider 2, 2 divides 2, 2 divides 6. Then for 3, 3 divides 3, 3 divides 6. And for 6, 6 divides 6. So all these order pairs will be included in relation D. Now we have to find L intersection D. Now check whether anything is common between these two relations 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 6. So I think all the order pairs are common between these two relations except 2 comma 3. So all remaining order pairs will be included in L intersection D as all these order pairs are common between L and D. So these kind of problems also they may ask you in exam. Have you understood this problem? Yes, have you understood? Or shall I repeat
Yes,
it?
ma'am.
Next question. Let R be the relation from x to y, x and y are given, which is defined by x divides y. Then write R as a set of order pairs. Find range and domain of R. So here we have to define relation R as a set of order pairs, and they have given one condition that x divides y. So here from this x and y we have to find all such order pairs. Those are satisfying condition x divides y. So do you want to try for this question? You have to just search for order pairs x divides y. For example, I will tell you one order pair 2 comma 6 because 2 divides 6. That's why we can include that order pair in relation R. So likewise, you have to find remaining order pairs. Now tell me another order pair for element 2. 2 comma is your voice is not audible.
10.
Yes, 2 comma
10.
yeah, because 2 divides 10. Now for 3 we can write 3 comma 3 as 3 divides 3, then 3 comma 6. Okay. Now for 4, I think there is no any order pair for element 4. For 5 we can write 5 comma 10. So all these order pairs we can include in relation R. Now check here. In each and every order pair, first element divides second element. Now here we have to find range and domain of relation R. So what is the range for this relation R?
6 comma 10 comma 3.
6 comma 10 comma 3, correct. And domain
2 comma 3 comma 5.
for domain, you have to check for first element of each and every order pair. So 2, comma 3, comma 5. So this will be a domain for that given relation. Next question. Let R be the relation in X where X is 2, 3, 4, 5, 6. Defined by X is in relation R with Y. This is equivalent to for any order pair X comma Y, X minus Y is divisible by 3. So we have to include such order pairs in relation R. For those X minus Y is divisible by 3. Okay. So now check in set X, 5 elements are there, and from these elements we have to construct a relation R. Those are satisfying condition X minus Y is divisible by 3. So I will tell you one order pair 3, 6 or 6, 3. Both the order pairs 3, 6 and 6, 3. Because 3, 6 it will give
2,
you
5.
yeah 2, 5 and 5, 2. Both are divisible by 3. Okay. So there will be total 4 order pairs. Next question. Set S is given and that is containing the elements from 1 to 10 and a relation R on S where R is equals to it will be consist of order pairs X comma Y such that X plus Y is equals to 10. Then what are the properties of relation R? So for this first of all we have to find what is a relation R. So we have to find such a order pairs such that the addition of those two elements X and Y that must be equals to 10. So I will tell you one order pair as 1, 9 and second one is 9, 1 because 1 plus 9 is equals to 10 and 9 plus 1 it is also equals to 10. That's why we can add these two order pairs in relation R. So likewise find out the remaining order pairs. Those we can include.
2, 8 and 8, 2.
Yes. 2, 8, 8, 2. Correct. 3, 7, 7, 2. Then
6,
next
4,
one
4,
is 6, 4, 4, 6. Any another order pair?
5, 5.
Yes, 5, 5. So all these order pairs we can include in relation R. Now we have to find out what are the different properties satisfied by this relation R. Now you have to tell me out of 5 properties, what are the different properties are satisfied by relation R? Now check from reflexive whether this relation is satisfying reflexive property.
No.
No. Okay. Whether it is symmetric. What is meaning of symmetric property? Yes, who will explain what is meaning of symmetric property?
It includes for every order pair A, D is B, A.
Okay. If A, B is there in relation R, it must include B comma A. Then only we can say that it is satisfying symmetric property. So here 1 comma 9 is here, so 9 comma 1 is also here. 2 comma 8, 8 comma 2, then 3 comma 7, 7 comma 3, 4 comma 6, 6 comma 4. So all such order pairs are here. That's why relation R is satisfying symmetric property. Okay. Now check whether this is transitive. What is meaning of transitive property?
Not transitive.
Not transitive. So what is meaning of transitive? If there is any order pair 1 comma 9 and 9 comma 1, then it must include order pair 1 comma 1. But not that is not here. That's why this relation is not transitive. Now check for irreflexive. Whether this one is irreflexive. What is meaning of irreflexive? A relation must not include any order pair x comma x. Then only that is irreflexive. But if you observe this relation, it is containing order pair 5 comma 5. That's why we can't say that this is irreflexive. Okay. And last one is a antisymmetric. Now check whether this one is antisymmetric. So what is meaning of antisymmetric? Yes. Who will explain antisymmetric property? Hmm. Mayur, are you there? Mayur Ghadge, roll number 50.
Hello, ma'am.
Yes. So, can you explain antisymmetric property?
So in this, the order pair A comma B, there will not be present at B comma A. Means mirror image is not present in it.
Mirror image. Is this correct? What we have seen for antisymmetric. If there is any order pair x comma y, then your relation must include y comma x, and meaning of this is x is equals to y. If this is true, then only we can say that that relation is antisymmetric relation. If you observe here, 1 comma 9 is there, 9 comma 1 is there. Yes, both the order pairs are present, but it is not correct that 1 is equals to 9. That's why this is not a antisymmetric relation. So we can say that out of 5 properties, only symmetric property is satisfied by given relation. Okay. And this is not irreflexive. I made here mistake. I have written here it is irreflexive, but this is not correct because 5 comma 5 is there. So this is not a irreflexive as well. So only symmetric property is satisfied by given relation here. So this kind of problems they may ask you for 8 marks. Okay. So from given condition, you have to find out what is the relation, that is set of order pairs, and then from those elements, you have to find what are the properties satisfied by that relation. And likewise, you have to write explanation for each and every property, whether that property is satisfied or not. If satisfied, then justification. If not, then as well you have to write their justification. Why that property is not satisfied by given relation. Then only you will get full marks. Next question is given. Determine whether the following relations are transitive. So first one is given, which is including order pairs 1, 2, 2, 2. Now check whether this one is a transitive relation. So what is your answer? Whether this one is transitive? Yes or no?
Yes, transitive.
Yes, transitive. Why? What is meaning of transitive property? If X is in relation R with Y and Y with Z, then X must be in relation R with Z. This is transitive property. Now here first order pair is 1, 2. So here we have to find any another order pair whose first element is 2. So 2, 2 is here. So 2, 2 will get cancelled and you will get order pair as 1, 2. And that order pair is present in this relation R. That's why this one is transitive. Now check for relation S whether this one is transitive. Yes,
Not transitive.
and not transitive. Explanation why it is not transitive.
2, 2 is not present order pair.
Order pair 2,
2,
2.
2 is not present.
How that 2, 2? Okay.
Order
So
pair
you
2,
have
1,
considered, yeah, 2,
2,
1 and 1, 2.
1,
Yeah.
2. 1, 1
So
gets
1,
cancelled.
1, yeah. And order pair 2, 2 is not included in relation S. That's why it is not a transitive. Okay. And last one is 1, 1. It is including just one order pair 1, 1. So whether this one is transitive. Yes, because here only one order pair is present. That's why it is not request to compare with second order pair and then check for whether third element is present or not. Okay, that's why this is a transitive relation. Next question is given. Let A is equals to set 1, 2, 3 and Cartesian product A is given. That is, this is a relation. Then we have to find out properties satisfied by following relations. So first relation is given as equals to relation. So from this we have to find out equals to relation such that first and second element of that order pair is equals to or same to each other. So likewise, we can include order pairs as 1, 1 because first element is set as that of the second element, then 2, 2 and 3, 3. So only these three order pairs we can include in this equals to relation. Okay. Now tell me what are the properties satisfied by this relation? whether this one is reflexive.
Yes, reflexive.
Reflexive. Why?
Order pair 1, 1, 2, 2, and 3, 3 are present.
Yes, because 1, 1, 2, 2 and 3, 3 is present in given relation. That's why this is a reflexive. Again, any another property? Here we can say that this is a antisymmetry because what is the meaning of antisymmetry? If x is in relation R with y and y with x, then x is equals to 1. And that condition is satisfied here because 1 is equals to 1, 2 is equals to 2, and 3 is equals to 3. That's why this given relation is reflexive and antisymmetry. Now next one is less than. So from all these order pairs, we have to find such a order pairs, those are satisfying less than property. So, first element must be less than second element. So, we can include order pair 1, 2, 1, 3, then 2, 3. So, only these three order pairs we can add in less than relation because first element is always less than second element. Now tell me what are the properties satisfied by this relation less than?
Transitive property.
Transitive 1, 2 and 2, 3. 2 to get cancelled 1, 2. Okay. Yes, it is a transitive. Any another property? Whether this one is reflexive.
Not reflexive.
Now check for whether it is irreflexive. Irreflexive आहे का हे relation? Yes, because this is not containing any reflexive element like 1, 1, 2, 2, 3, 3. So such a order pairs are not here. That's why we can say that this is a irreflexive. Now check whether this one is a transitive pair object, whether this one is a antisymmetric. No, this is not a antisymmetric. And symmetric.
Not symmetric.
No, that.
So it is a irreflexive and transitive. Now likewise we have to find for greater than relation. So we have to find such order pairs whose first element is greater than second element. So we can include order pairs as 2, 1, 3, 1 and 3, 2 because in all these order pairs first element is greater than second element. Now check whether this one is a transitive. Because if you consider order pairs 3, 2 and 2, 1, 3 will get cancelled and you will get 3, 1. That's why this one is a transitive. Now check whether this one is irreflexive. Yes, this is irreflexive because there is no any order pair 1, 1, 2, 2, 3, 3 like this. That's why this one is a irreflexive. Now next question is given. We have to find all such order pairs. Those are satisfying condition less than equals to. So from all these order pairs, we have to find such order pairs. Those are satisfying less than equals to relation. So 1 comma 1 we can include as 1 is equals to 1. 1 comma 2 we can include as 1 is less than 2. Then 1 comma 3. Then 2 comma 3 and 3 comma 3. So all these order pairs we can include in less than relation. Now check whether this one is a reflexive. We have defined this relation on set A, and that is containing three elements as 1, 2, 3. So in order to satisfy reflexive property, that relation must include 1 comma 1, 2 comma 2 and 3 comma 3. And all these order pairs are here. That's why we can say that this relation is satisfying reflexive property. Now check whether this one is symmetric. So for symmetric property, if your order pair 1 comma 2 is present, then 2 comma 1 must be there. But that is not here. So we can say that this is not a symmetric relation. Now check for transitive. So in order to find whether this relation is transitive or not, this is a transitive. Why? Because if you consider order pair 1 comma 2 and 2 comma 2, then 2 will get cancelled. We will get 1 comma 2 again. That is present here. So another order pair we can consider as 1 comma 3 and 3 comma 3. So again 3 will get cancelled. We will get 1 comma 3. So that order pair is also present here. So 2 comma 2 and 2 comma 3. So again 2 will get cancelled. You will get 2 comma 3. That is also present here. That's why we can say that this is a transitive relation. Now check for antisymmetric. Yes. This is including reflexive elements. So we can say that this is a antisymmetric as well. Because every reflexive relation is a antisymmetric relation. That's why you can say that this is a antisymmetric as well. And last relation is greater than equals to. So first of all, we have to find the order pairs. Those are satisfying greater than equals to property. So now tell me what are the different order pairs we can include in greater than equals to. So here we have to find such order pairs whose first element is either equals to or greater than second element.
1 comma 1, 2 comma 1, 2 comma 2,
2 comma 2. Okay.
3 comma 1, 3 comma 2 and 3 comma 3.
Yes. So all these order pairs we can include in this greater than equals to. So again we have to check for what are the different properties satisfied by these. Again it is including order pairs as 1 comma 1, 2 comma 2 and 3 comma 3. This is reflexive, and we have seen every reflexive relation is satisfying antisymmetric property. So this is reflexive and antisymmetric. Now check for transitive. So here 2 comma 1, 1 comma 1. 1 1 will get cancelled, you will get 2 comma 1. That is present. Again, if you consider 2 comma 2, 2 comma 1, again 2 2 will get cancelled, you will get 2 comma 1. That is also present here. If you consider 3 comma 1, 1 comma 1, 1 1 will get cancelled, you will get 3 comma 1. That is also present here. If you consider 3 comma 2 and 2 comma 2, again 2 2 will get cancelled, you will get 3 comma 2. Again 3 comma 2, 2 comma 1. 2 2 will get cancelled, you will get 3 comma 1. That is also present. So likewise, it is satisfying transitive property for each and every order pair. That's why this relation is transitive. So three properties are satisfied and reflexive, antisymmetric, and transitive. So next question is given. Set S is given, which is containing three elements 1, 2, 3, and a relation R on S defined by R is equals to the pairs 1, 2, 4, 3, 2, 2, 2, 1, 3, 1. Now show that a relation R is not transitive and find a relation where R1 includes R such that R1 is transitive. Okay. So first of all, we have to show that this relation R is not transitive. Now you have to tell me how we can justify for this statement. How we can show that R is not transitive.
For order pair 4, 3 and 3, 1. 3 3 get cancelled and 4, 1 is not present.
Okay. 4, 1 is not present in given relation. So R is not transitive. So how we can make this transitive? We have to find any relation R1 such that R1 is transitive and R1 includes R. So we have to find any relation such that R is subset of R1 and R1 is transitive. म्हणजे काय R चे जेवढे एलिमेंट आहेत ते सगळे R1 मध्ये पाहिजे प्लस R1 हा ट्रान्सिटिव्ह पाहिजे म्हणजे काय आपल्याला अजून कोणते तरी ऑर्डर पेअर ऍड करायचे ज्याने R1 हे ट्रान्सिटिव्ह रिलेशन होईल. That is meaning of R1 includes R. Yes. So first of all, we have to find out what are the different order pairs are required to make this RS transitive. So first order pair we have seen, and that order pair is 4, 1. Now check whether there is any another order pair we need to include. I think only one order pair is there, so we can add that order pair here. 4, 1. Okay. So now check R1 is transitive and R1 is containing all the order pairs from relation R. So we can say that R1 includes R, or we can say R is subset of R1. Okay. So here both the conditions are satisfied. First one is R1 is transitive and R1 includes relation R. So likewise, we can solve these kind of problems. Have you understood? Do you have any doubt regarding any question? Things so far we have seen. So I hope you have understood all these questions. So now we will see some more questions on properties of relation. Then we will move to the next point from this chapter. So all these questions are based on properties of relations only. So question number 1 is given. For each of these relations on set 1, 2, 3, 4, decide whether it is reflexive, whether it is symmetric, whether it is antisymmetric, and whether it is transitive. So out of these all properties, we have to check what are the different properties satisfied by given relation. So first one is given as set, which is containing order pairs as 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, and 3, 4. Now start with reflexive property and now check whether this given relation is reflexive. So in order to make this reflexive, it must include order pairs 1, 1, 2, 2, 3, 3, and 4, 4. Because we have defined this relation on set which is including elements as 1, 2, 3, 4. But out of these 4 order pairs, our relation is just containing 2, 2, and 3, 3. So 1, 1 and 4, 4 are missing here. That's why this is not a reflexive relation. Now check whether this one is a symmetric. Symmetric property. Right? If there is any order pair 2, 3, then 3, 2 must be there in our relation S. For this 2, 3, 3, 2 is present. But if you consider 2, 4, now check whether 4, 2 is here. No, that's why this is not a symmetric. Now check for anti-symmetry. No, this is not a anti-symmetry. But here 2, 3 and 3, 2. Both of the pairs are present, but its meaning is not like 2 is equals to 3. That's why this is not a anti-symmetry. And check for transitive, whether this one is a transitive. Ratan Kore, can you tell me whether this relation is transitive? Ratan Kore, are you there? Umesh Mandani, can you tell whether this one is a transitive? Not transitive. Why? Because if you consider order pairs like 2, 3, 3, 2, 3, 3 will get cancelled, you will get 2, 2. That is present here.
Yes, madam.
If you observe transitive.
Transitive.
Okay. Yeah. We have to check for all such order pairs. And for every pair of orders, if it is satisfying transitive property, then only we can say that it is transitive. Now, again we can take another example as 3 comma 3, 3 comma 2. So again 3 will get cancelled, you will get 3 comma 2, and that is also present here. So it is satisfying transitive property for every pair. That's why this is a transitive. Now, second relation is given. Again, you have to find what are the properties satisfied by this given relation. So, start with the reflexive property. So, whether this one is reflexive, we have defined this on set, which is containing four elements: 1, 2, 3, 4. So, now check whether this one is reflexive.
Yes, ma'am, reflexive.
Yes, madam. Reflexive.
Property, and that property is symmetric. Whether this one is symmetric. Symmetric means what? Reverse of,
Yes,
yeah, reverse of every other pair must be there. So here 1 comma 1 reverse is same, 1 comma 2 reverse is 2 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 reverse is again same. So we can say that reverse of each and every other pair is here. That's why this one is a symmetry. Now next property is antisymmetric. Antisymmetric आहे का? No, this is not a antisymmetry. Why? Because 1 comma 2 is there, 2 comma 1 is there. It is not the same that 1 is equals to 2. That's why this is not a antisymmetry. And last one is transitive. Check whether this one is transitive.
yes, ma'am. Transitive.
Yes.
Yes.
Transitive. Correct. So tell me whether this one is a reflexive relation. What are the properties satisfied by this relation C? Reflexive आहे का?
No reflexive.
Whether this one is symmetric.
Yes, symmetric.
Is symmetric. Whether this one is transitive. No,
Not
because
transitive.
yeah, and asymmetric.
Not antisymmetric.
Irreflexive. Irreflexive आहे का? Yes, because there is no such a reflexive element like 1 comma 1 2 comma 2. Such element is not here. That's why this one is irreflexive. Only one property is satisfied. Now for this
Symmetric also, madam.
symmetric and irreflexive. So now we have to find the properties satisfied by relation D. Start from reflexive. Whether this one is reflexive.
Not reflexive.
Okay. Symmetric.
Not symmetric.
Transitive.
Not transitive.
Irreflexive.
Yes.
Yes, it is a irreflexive. Antisymmetric. No, it is not a antisymmetric as well. That's why only one property is satisfied and that is irreflexive. Continue. This is last set last relation from this question. So what are the properties satisfied by this relation E? Whether this one is reflexive.
Yes, reflexive.
Yes.
Okay. Antisymmetric. Antisymmetric असेल की नाही? Yes, because what we have seen, every reflexive relation is a antisymmetric relation. That's why if this is symmetric, then it must satisfy antisymmetric property as well. Now check whether this one is symmetric.
Yes, ma'am.
Yes, symmetric.
Okay. And what is remaining? Irreflexive. No, this is not irreflexive because reflexive elements are here. And transitive.
Yes,
What
transitive.
about transitive? No transitive
Transitive, ma'am.
is transitive because
Transitive,
first
transitive.
order pair is 1 comma 1. Then if there is any another order pair whose first element is 1, then only we are going to check whether that result or result whatever new order pair we have obtained that is present in relation or not. But here if you consider any order pair like 1 comma 1, there is no any another order pair whose first element is 1. Like let's go to again there is no any other pair whose first element is 1. That's why we are going to skip all these order pairs. If both the order pairs present, then only we are going to check for result. That's why this one is transitive. Yes. Relation F is also there. So what are the properties satisfied by this relation? Reflexive आहे का? नहीं है. Because 1 1 2 2 3 3 4 4 all these orbitals are not here. Now symmetric.
Not symmetric.
Not symmetric. Why?
Symmetric.
4,1 is not present.
2,3. Okay. Now next one, transitive.
Not transitive.
Not transitive. Antisymmetric. If this is not reflexive, then not antisymmetric as well. And last one, irreflexive.
Yes, irreflexive.
Irreflexive, because there is no such any reflexive factor. So all these examples were based on properties of relations only. So all these, it was part of revision. Now today we are going to see the remaining points from unit number 4. That is relations. So now today we have to see the next point is relation matrix and graph of relation. So till so far we have seen how we can define any relation, how we can find out what are the different properties that is satisfied by given relation. So now we have to find the matrix for given relation and graph of that given relation. Okay. So first of all we have to see what is the definition for relation matrix. A relation R from finite set X to finite set Y can also be represented by a matrix, and that matrix is called as relation matrix of R. So in the simple way we can say that any relation can be represented with the help of matrix, and that matrix is called as a relation matrix. Okay. So suppose set X and set Y are given, those are containing some elements. Then set X will represent row of that matrix and set Y will represent column of that matrix. Okay. So here they have
No,
given
ma'am.
one example. Yes.
मॅम
Hello.
स्पीड खूप फास्ट व्हायला लागलाय.
अजून एक्झाम्पल सांगितलंच नाही. एक्झाम्पल सांगितलं तुम्हाला कळेल म्हणून थोडं बरं Now consider here they have given one example where m is equals to 3. So m means what? Here they have given m for number of rows and n for number of columns. Okay. And that relation R is given as order pairs x1 y1, x2 y1, x3 y2, x2 y2. So all these are the order pairs of relation R. Now from this relation we have to find the matrix for this given relation. So again we have seen what is the matrix for any relation. again that matrix will be consist of rows and columns. Okay. So first element of each and every order pair that will represent row of that matrix. Now check here how many unique elements are there. So x1 is there, x2 is there, x3 is there, again x2 is there. So we can say that three rows will be there in matrix as x1, x2 and x3. And those three elements are we have taken here as rows. Okay. And second element will represent column of that matrix. Now check here for second element from each and every order pair, and that is y1, y1, y2, y2. So we can say here there will be two columns as y1 and y2. So this is formation of matrix. Now we have to check where we have to write 1 and 0. If that respective order pair is present in relation R, then that will be represented by 1. If that order pair is not there, then we are going to write there 0. Now, first one is x1, y1. Now, this order pair is here in the relation. That's why x1 is row, y1 is column. And for this order pair, we have to write there 1 as that order pair is present in our given relation. Now check for x1, y2. Now check whether that x1, y2 is present in given relation. No, that order pair is not here. That's why we have to write 0 there. Okay. Now next one. If you consider second row x2, y1, that is the order pair. Now check whether x2, y1 is present here. Yes, that is present in given relation. So that must be represented by 1. Now check x2, y2. So whether x2, y2 is present? Yes, that is also present. That's why we have to write here 1. Now move to the next row, and that is x3. So x3, y1. Whether that order pair is here? No. That's why we have to write 0 there. And last one is x3, y2. Now that order pair is present in given relation, so we have to represent it by 1. So in this way, we can find matrix for any relation. Now tell me, have you understood how to find matrix for given relation? समजले का रिपीट करायचे?
रिपीट करा मॅडम एकदा.
ओके. रिलेशन मॅट्रिक्सची डेफिनेशन समजली का? Matrix which is drawn for representation of any relation is called as relation matrix. As simple as. Okay. Now, here one example is given, which is consist of order pairs. Okay. Now, for this relation R, we have to draw a we can say relation matrix. Okay. So first of all, we have to identify how many rows will be there and how many columns will be there for given relation in relation matrix. Okay. आता काय म्हटलं, प्रत्येक ऑर्डर पेअरचा पहिला एलिमेंट हा रो असणार आहे आणि सेकंड एलिमेंट हा कॉलम असणार आहे. सो फर्स्ट ऑफ ऑल check how many unique rows or unique elements will be there in each and every order pair as a first element. आता फर्स्ट एलिमेंट प्रत्येक ऑर्डर पेअरची चेक केली तर काय येणार x1, x2, x3, again x2. So here we can say that only 3 unique elements are there as x1, x2 and x3. That's why we are going to consider all those first element as rows. So there will be 3 rows as x1, x2 and x3. Okay. Now first of all, we have defined only number of rows. Now we have to check for number of columns. So again, there should be unique elements for number of columns. So again, second element from each and every order pair will refer to columns. So second element y1, y1, y2, y2. So here only 2 unique elements are there, y1 and y2. That's why This matrix will contain two columns and those columns are y1 and y2. इथपर्यंत समजलं का? रोज एंड कॉलम्स कसे डिफाइन केले? हॅलो, हॅलो.
Yes, ma'am.
Okay. So now we have to check what are the elements are present in relation. एक तर तुम्ही ह्या मॅट्रिक्स वरून रिलेशन बघू शकता किंवा रिलेशन वरून मॅट्रिक्स मध्ये 1 किंवा 0 रिप्रेझेंट करायचं. Okay. Now if you consider first order pair x1 comma y1. Okay. So x1 is row, y1 is column. So x1 is row, y1 is column. So that element is present in this given relation. So we have to represent it by 1. Okay. So we have written here 1. Now next element is x2 comma y1. So x2 is row, y1 is column. That element is present. So again we have to write here 1. Next element is x3 comma y2. So x3 is row, y2 is column. So again we have to write here 1. And last element is x2 comma y2. So x2 is row, y2 is column. So again we have to write here 1. And for all remaining places we have to write 0 because those elements are not present in given relation. So this is the relation matrix we have drawn for this given relation R. समजलं का? जेवढे ऑर्डर पेअर असतील तिथे 1 लिहायचं, जे ऑर्डर पेअर नाही आहेत प्रेझेंट त्यासाठी 0 लिहायचं. अंडरस्टूड नाउ?
Yes, ma'am.
And that is again given here. We have to write 1 if xi are y. This one, if that order pair xi comma yi present in given relation R ij, then only we have to write 1. If that order pair is not present in given relation R, then we have to write 0. Now we have to see what are the different relations. Okay, so here we can say that this relation is a reflexive relation. Why? Because x is in relation R with x. In short, that R is coming from node x or element x, and again it is stopping at x only. In short, x is in relation R with x. There is loop or self loop, we can say. So this is a reflexive relation. Now, for here again x and y, these are the two elements. So how we can represent it? X is in relation R with y because there is R from x to y. That's why x is in relation R with y. So again, how we can define this one? This graph, x is in relation R with y and y is in relation R with x because there is R from x to y and y to x. That's why x is in relation R with y and y is in relation R with x. If you observe this graph, we can say x is in relation R with y, y and y is in relation R with z, and z is in relation R with x. And last one, x is in relation R with y and y is in relation R with y because there is self loop at y. So in this way we can define graph for any relation. Are you getting this? How to draw graph for relation? Hello. परत सांगायचंय का?
Yes, ma'am.
So while representing any relation with the help of graph, we have to represent every element of that relation as a circle, and we have to draw a arc from that element to represent its relationship with another element. Okay. Now suppose if your relation is containing any order pair x comma x, okay, and now we have to represent it with the help of graph. So x is the element here. That's why we have to represent it by circle. Now x has a relation with element x itself. That's why we have to draw a arc, and that is starting from x and ending at x only, because that order pair is x comma x. That's why we have represented that order pair using this graph. So what is meaning of this? X is in relation R with X, or we can say that order pair X comma X is present in given relation. Okay. Now, if there is any order pair X comma Y in relation, then how we can represent it? Again, for this order pair X comma Y, two elements are there, that is element X and element Y. So two separate elements are here. That's why we have to represent these elements by circle. So there will be two circles. One is for x and one is for y. Now x is in relation R with y. Therefore, that R must be start with x and should be end at y. So x is in relation R with y, and that is drawn here by this arrow. Here's the assertion y is in relation R with x. Then we have to reverse the order of this arrow. That should start with y and ends with x. Okay. But here they have given x is in relation R with y. That's why arrow from x to y. Now next is given as x is in relation R with y and y is in relation R with x. So again here two elements are present as x and y. So we have to represent it with the help of circles. So first one is x is in relation R with y. Because that R must be start with x and ends with y. And y is in relation R with x, because it must start with y and ends with x. That's why this is represented by both the arrows from x to y as well as from y to x. Now, next one is x is in relation R with y and y is in relation R with z, and z is in relation R with x. In short, first of all, we have to identify here three elements are present as x, y, z. So we have to represent these three elements with three circles. Okay. Now x is in relation R with y. In short, there should be R from x to y. That is the first one. Now, second condition is given as y is in relation R with z. So there should be R from y to z. And last one is given as z is in relation R with x. Means again there should be R from z to x. So this is the graph for this given relation. And last one is given as x is in relation R with y and y is in relation R with y. So again we can identify here two elements are there, that is x and y. So we must represent these two elements by circles, as one circle is for x, another is for y. And first condition is given as x is in relation R with y. Therefore, there should be R from x to y. And second one is given as Why is it relation arc is 1? Because there must be a self loop. Because that arc is starting from y and ends at y only. That's why that is a self loop. So in this way, we can draw graph for any relation. Have you understood now? What is the graph of relation? Oh, sorry. So today we are going to stop here. Remaining points we will see next lecture. Give me presenting. Roll number 1,
Yes, ma'am.
2, roll number 2, 3,
Yes, ma'am. Yes, two present, ma'am.
okay, 3,
Yes, ma'am.
4,
Present, ma'am.
5,
Present, ma'am.
6,
Present, ma'am.
7,
Present.
8,
Present, ma'am.
9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12, roll number 12, 13,
Present, ma'am.
14,
Present, ma'am.
15, 16,
Present, ma'am.
17,
Present, ma'am.
18, 19,
Present, ma'am.
20, 21, 22,
Present, ma'am.
23,
Present, ma'am.
24,
Present, ma'am.
25,
Yes, ma'am.
26, 27,
Present, ma'am.
28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31,
Yes, ma'am.
32, 32, 33, 34,
Present, ma'am.
35,
Present, ma'am.
36, 37,
Present, ma'am.
38,
Present, ma'am.
39,
Yes, ma'am.
40,
Present, ma'am.
41, 42,
Yes, ma'am.
43, 44, 45,
Yes, ma'am.
46, 47, 48,
Yes, ma'am.
49,
Yes, ma'am.
50, 51,
Present, ma'am.
52,
Yes, ma'am.
52. Who is 52? 53. Okay.
Hello, ma'am. To the mic band.
54,
Yes, ma'am.
55,
Yes, ma'am.
56,
Yes, ma'am.
57,
Yes, ma'am.
58,
Yes, ma'am.
59, 60,
Yes, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66,
Present, ma'am.
67,
Present, ma'am.
Yes, ma'am.
Present, ma'am. 66.
68,
Present, ma'am.
69,
Present, ma'am.
70.
Present, ma'am.
Okay. Now check for today's option numbers. Roll number 12, 15, 20, 21, 26, 32, 33, 36, 41, 43, 44, 46, 47, 50, and 64.
Madam, 50 is present.
Remember 15.
Ma'am, 20.
20. Assume that. So today we are going to stop here. Thank you.